Hello everybody, this tutorial is on polar and nonpolar covalent bonds. So first we're going to talk about what the heck bond polarity is, and then how you know when a bond is polar or not, and then how you designate bond polarity. Alright, so first let's talk about what bond polarity is. So we've been talking about covalent bonds, and we've been talking about how a covalent bond is when two atoms are sharing pairs of valence electrons. So just like when anything is shared, sometimes that sharing is equal, and sometimes an atom hogs the electron from the other atom. So a bond where the atoms are sharing their electrons equally is called a nonpolar covalent bond. And a bond where where one atom is hogging the electrons from the other is called a polar covalent bond. So let's talk about some examples of which elements or which types of covalent bonds would be considered a nonpolar covalent, and then what would be considered polar covalent. So something like H2, or dihydrogen, or hydrogen gas, as we like to call this, is, two hydrogen atoms sharing a pair of electrons. And that pair of electrons belongs equally, or is shared equally, between the two hydrogens. So how do we know that it's shared equally? Well, we base this on electronegativity values. Because since this hydrogen is just as electronegative as this hydrogen, they're both equally as attractive to those two electrons, and so those electrons will roughly spend their time evenly between the two hydrogens. So it's all about electronegativity difference. So we would consider the bond between two hydrogens, this covalent bond, a nonpolar covalent bond because they share those electrons equally. All right, so here's a picture of what the electron density around, say, two hydrogen nuclei would look like. You've got, roughly an equal density around each because they're sharing that pair of electrons pretty equally. So that's a nonpolar covalent bond. What about something like the bond between hydrogen and chlorine and hydrochloric acid? So we have two nonmetals, and again, they're sharing a pair of electrons. But what you're going to find is that hydrogen's electronegativity is less than that of chlorine's. So chlorine is going to sort of hog the electrons away from the hydrogen. So those electrons are going to spend more of their time, closer to the chlorine and further from the hydrogen. So even though they're sharing that pair of electrons is much more attracted to the chlorine than it is to the hydrogen. All right, so again, because the electronegativity difference of chlorine is greater than that of hydrogen, this bond is considered polar covalent. So a polar covalent bond, if you think about what polar means, like the Earth has poles or a magnet has poles. Polar means you've got two oppositely charged ends to this bond. So if we look at the chlorine end of this bond, because those electrons are closer to the chlorine, that makes chlorine have a partially or slightly negative charge compared to the hydrogen, which ended up slightly positive by comparison. Again, because the electrons are negative and they're spending more time around the chlorine, makes chlorine slightly negative. So this bond has poles. So this picture designates or shows a polar situation where, say, the hydrogen and the chlorine in this instance, you can see the electron density is larger around the chlorine because those electrons spend more time around it. So a way to, just a little cute cartoon that might sort of make this a little clearer, a nonpolar covalent would be like, say, two polar bears sharing an ice cream cone. They're each pulling on the ice cream cone equally, so they're sharing those electrons equally. or two penguins doing the same. They're sharing equally, whereas a polar covalent would be like a penguin sharing an ice cream cone with a polar bear. So even though the penguin might get to lick the ice cream occasionally, the polar bear's stronger and is pulling on the ice cream a little bit more. So the question becomes then, how do you know when a bond is polar or not? So the way to know when a bond is polar or not is you've got to look at the difference in electronegativity between the two elements involved. So how do you know the electronegativity values? Well, I'm going to give you a table that looks very similar to this table right here. And I want you to ignore the noble gases because for our purposes, noble gases have zero electronegativity. So for a hydrogen-chlorine bond, for example, how did I know that that hydrogen-chlorine bond is for sure a polar bond? Well, I can look at the electronegativity of hydrogen and chlorine and I can subtract. So I can see that hydrogen is 2.1 and chlorine is 3.0. And if I subtract 2.1 from 3.0, I get a difference of 0.9. And then you need to have ranges. So your ranges that would be considered polar are anything between 0.4 and 2.9 would be considered your polar covalent bonds. And you're going to need to write that down. You'll need to know that range. So that's how I knew that my hydrogen chloride bond was a polar bond, because this fell in that range of differences of electronegativity. And the same is true for the bond between hydrogen and, say, I don't know, carbon. So if I have a bond between hydrogen and carbon, the hydrogen is a 2.1 electronegativity and carbon is only 2.5. So if I subtract 2.1 from 2.5, I only get 0.4. And so our range of electronegativity from 0 to 0.4 would be considered a nonpolar covalent bond. We would roughly or say that those electrons between the hydrogen and the carbon are being shared roughly equally. And with that said, we might as well talk about ionic, because sometimes you have a situation in which you have a bond like, say, lithium and, I don't know, fluorine. So the bond between lithium and fluorine, we already know that's ionic because lithium's a metal and fluorine's a nonmetal. But it's so if you look at the electronegativity difference, it actually makes sense. If lithium's 1 and fluorine is 4, you get a difference of 3, right? And that difference is way over the range of being considered covalent. In fact, this is where you get into ionic. So ionic bonds have an electronegativity of greater than 2. So just as a reminder to you, you need to write these ranges down, and then you need to also know that I will give you a table that looks like this in class so that you can tell the difference between nonpolar and polar bonds. And then also, if you're wondering if a bond is ionic or not, which, again, metal and nonmetal is generally ionic, you'll at least know that anything over an electronegativity value or difference of 2 would be considered ionic. So the last thing we're going to talk about in this video is how you would designate whether or not a bond is polar. So how would you indicate that? Because you're going to have to do that. So in order to do that, I'm going to do an example here. So we just got done talking about a carbon-hydrogen bond. And I told you that the electronegativity difference between carbon and hydrogen, so carbon had an electronegativity of 2.5 and hydrogen was 2.1, which makes the difference between the two only 0.4. So anything below 0.4 is considered nonpolar. So if I were to ask you to designate this bond polarity, what I would want you to do is I would want you to just say it's nonpolar. It's not a polar bond. But what if it were polar? If it is polar, there's 2 ways that you can designate bond polarity. And the first way is with something called polarity arrows. Now, polarity arrow looks like this. It's got it's an arrow, and one end of the arrow has a cross on it to indicate positive, and then the arrow shows the direction that electrons are being pulled. So for example, in our hydrogen-chlorine bond, hydrogen has a polarity of 2.1 and chlorine is 3.0, and the difference between is 0.9, which falls in the range of being polar. So to designate the polarity of the bond, we would want to use either a polarity arrow, which shows that these electrons are being pulled more towards the chlorine with the larger electronegativity. So we would draw the arrow over the two atoms with the arrowhead over the chlorine to show that those electrons are pulled towards the chlorine, and then the crossed end over the hydrogen to show that hydrogen ends up positive by comparison because the electrons are pulled away from it. The other way that you can designate bond polarity is, again, we'll use this hydrogen chloride bond as an example. So this is just an alternative, is to use something called partial positive and partial negative symbols. So if those electrons are being pulled more towards the chlorine, they're still being shared, right? That wouldn't make chlorine completely positive, or sorry, negatively charged, but definitely it would give it a partially negative pole, and then hydrogen would be a partially positive pole or end to those bonds. So just know that I will make you know both polarity arrows and the partial positive, partial negative symbols. You should be able to use either one, and then of course on a test, if I were to ask you to designate whether or not a bond was polar, I would expect you to use either one of these and pick the one you like the best. I personally like the arrow because it's more visual, but that's just me. And one last thing, how would you do this or designate bond polarity in an entire molecule? So now we're talking about a whole molecule that has more than one bond. So how about CH2Cl2, this molecule? Well, these are all covalent bonds, and we just want to know if they're polar or not. So we've already discussed how a carbon-hydrogen bond, like this bond or this bond, are considered nonpolar. And so I would expect you to write an NP next to both of those bonds so that I know that they're not polar. But the other two bonds are polar. Their carbon-chlorine bonds are considered polar because carbon has an electronegativity of 2.1 and chlorine has an electronegativity of 3. And the difference between those is enough to be, 2.5 and 3. So the difference between those is enough to be considered polar. And so polar towards the chlorine. So you should be able to show me that those two bonds are considered polar bonds by either using the arrow, or again, you could have used the partial positive or partial negative symbols. So that brings us to the end of the presentation on whether or on polar and nonpolar covalent bonds.